All right, let's build a really fun piecewise function because we've had so much fun with piecewise functions because we can really use them to describe limits and now, as we've seen, to really describe interesting situations with continuity. And what we're going to do is we're going to take this piecewise function we're about to build and we want to state the intervals on which the following function is continuous. All right, and now let's build a really fun piecewise function that has 4 different parts to it. So we're going to let f of x equal, and we're going to start off with an exponential piece. We're going to look at 3 raised to the x power, and we'll let that be for all x less than 0. And remember, I can put in negative values of x here. It just gives us a negative exponent. So like 3 to the minus 1 would be 1/3. So I'm okay with negative values as an exponent. Then let's define it as sine of x for 0 less than or equal to x less than or equal to pi over 4. And then at pi over 4, let's change it to cosine of x. So the cosine of x and we're going to call this pi over 4 less than x less than pi. And then for x greater than pi, will look like the function 1 over x minus 4. So a lot going on here, and we'll actually call that, that should be greater than or equal to pi. So there's our piecewise function. Okay, as we're doing our work, I'm going to have a couple of things that I'm keeping track of. One is I'm going to list where we are finding that this function is discontinuous. So I'm going to have a list here of my discontinuities. And I'll tell you right now that I already see one right off the bat. 3 to the x, sine of x, cosine of x, those are all continuous functions across their domains. 1 over x minus 4 is continuous for its domain, but its domain excludes the value 4 because 4 cannot be in the denominator. Now then, we also should check to make sure that the function is actually being defined at 4 for this piece, and 4 is greater than pi. So yes, I already know I have a discontinuity at x equals 4. If I plug 4 into this function, I need to put it into the part that's greater than pi, and it comes out undefined right there. So x equals 4 is automatically a discontinuity. The other thing that I'm going to keep track of over here is I'm going to keep track of some intervals where this function is continuous. And as I'm building this list, it's going to be really important to understand that we are talking about saying the function is continuous on this interval. However, whenever we get this list, and there's going to end up being 4 intervals where we could say the function is continuous on this interval, it's not a situation where we union them together or anything to get an answer. We're going to get 4 different answers where we could say, yeah, this function is continuous on this particular interval because it meets our criteria. So I already said at x equals 4 I have a discontinuity. The other places I need to look at, whenever piecewise functions are redefined, I need to go see what happens there. So I change what my function looks like at x equals 0. So I am going to address what happens at x equals 0. I also do the same thing at x equals pi over 4. And so I need to address what happens at pi over 4. And then I also need to address what happens at x equals pi because I change the definition of my function there. So let's talk about x equals 0 here. Well, I already know that f of 0 is equal to, if I substitute 0 in because of the equal sign, I need to say that f of 0 is equal to the sine of 0, which is 0. So I've got f of 0 equals 0. All right, let's take a look now at the limit as x approaches 0 from below of f of x. As I look at values to the left of 0, they need to be substituted into this piece right here. That equals 3 to the 0, which is 1. Remember that any non-zero number raised to the 0 is equal to 1. So I can already see I'm going to have a break in continuity there. So I have a discontinuity at x equals, that should be 0 right there. X equals 0, I have a break in continuity. So let's take a look at the limit as x approaches 0 from above of f of x. Well, for values greater than 0, I need to substitute it into sine of 0, which is in fact 0. So I know that 3 to the x, I can plug in any number headed out towards negative infinity into that function. So when I talk about my intervals on which I'm continuous, I am continuous on the interval from negative infinity. I do have a break at 0. So at 0, my function stops being continuous. Now the question is, do I need to close 0 off or leave it open? Well, if 0 is my right endpoint, I need to see what happens as I approach 0 from the left. As I approach 0 from the left, I'm at 1. That does not match my function value, so I actually cannot close this off. Okay, so I am continuous on the interval from negative infinity to 0, but I can't include 0 in this particular interval. All right, let's take a look now at x equals pi over 4. So f of pi over 4 is equal to, well, if I find my equal sign here, that's sine of pi over 4, which is the square root of 2 over 2. So now if I take a look at my one-sided limits, if I look at x approaching pi over 4 from the left of f of x, as I approach it from the left, I am looking at values. Again, I'm looking at sine of pi over 4, which is still the square root of 2 over 2. It didn't change in the last couple of minutes. As I approach pi over 4 from above, though, so x approaching pi over 4 from above, well, values greater than pi over 4, I'm looking at cosine of x. So that is going to direct substitute into cosine of pi over 4. It just so happens that that is also equal to the square root of 2 over 2. And since my one-sided limits match, I can say that the limit as x approaches pi over 4 of f of x is equal to the square root of 2 over 2. And that happens to equal f of pi over 4. So I don't have a discontinuity at pi over 4, even though my function did redefine itself at pi over 4. Okay, now let's take a look at what happens at x equal to pi. So at x equal to pi, I know right off the bat that f of pi is equal to 1 over pi minus 4, which is some value. It's some negative value, but it's some value right there. So now let's take a look at the limit as x approaches pi from below of f of x. And I'm going to kind of run out of room here, so I'll remind you, for values less than pi, we're looking at, I'll go ahead and write it in there, the cosine of pi, which is equal to negative 1. And already I can see I don't have that equaling to f of pi, so I'm going to end up with a discontinuity at x equals pi. But let's go ahead and take a look at the limit as x approaches pi from above of f of x. Well, we already know for values greater than pi, we end up with 1 over pi minus 4. So I have a break in continuity. Let's see, we already addressed the one at 0. So my continuity re-picks up at 0. Now then, when I'm at 0, let's go ahead and try to articulate here what I'm trying to say. I'm able to stay continuous from 0 to pi. The question is, do I close these off or not? Well, over here on the left endpoint, I need to look at what f of 0 is. F of 0 was 0. As I approach 0 from the right, I'm at 0. So I can actually close off 0. Now then, for pi, which is my right endpoint, I need to know that f of pi was 1 over pi minus 4. As I approach pi from the left, I'm at negative 1, however, so I do have an open interval there. And this is where I said earlier, this is not any kind of thing where you would union these together. This is just a list of intervals where my function is continuous. So I could say, yeah, this function is continuous from negative infinity to 0, but not 0. I can also say that it's continuous from 0 to pi and includes 0. But this is, again, not a situation where I would union them together. I also know that from pi to 4, I don't have a break in continuity. Now then, f of pi was this value right here. As I approach pi from the left, as I approach pi from the right, my left endpoint matches that value, so I can actually close pi off here when I list this. Now then, f of 4 is simply undefined, and so that's going to be open. And then from 4 to infinity, I also know that this piece of the function stays continuous. Now then, again, f of 4 is undefined, so I can't close it off, and then we don't ever close it off with infinity. So each of these 4 intervals, it is a true statement that f of x is continuous on those intervals. But again, that's not a situation where you would then try to mash those 4 intervals together, because if you were to try to do that, you would end up actually including 0, and you would do some things that would say what you're not trying to say. All I'm saying right now is that on any of these 4 given intervals, I could say that the function is continuous across that interval.